Alright, so in the last video, we talked about direct variation. So now we have inverse variation, which is kind of just like the opposite. So it tells us at the top that for the inverse variation equation is xy equals k, where k is that constant. I like to rewrite this, and you'll see it in different ways. This is one way to look at it. I'm going to show you the way I like to write it. It just makes more sense in my head, but use whatever works best for you. So I like to write this as y equals k over x. I just like it to be y equals. It helps us later in this packet, but again, use whatever you're more comfortable with. Both are valid. So it wants you at the bottom to graph each variation of x varies inversely, or y varies inversely as x. So you're just going to be using this equation we have here to graph the inverse relationship. So at the top it suggests one way to do it. I'm going to offer a second way that just makes a little bit more sense in my mind, but use whatever way makes most sense to you. So it says, for number one, it says y equals 9 and x equals -3. So the reason I liked this to be y equals, that's kind of how we see functions when we're graphing them. It's always y equals. So I'm going to take this, I'm going to plug it in to this equation here. So we have 9 equals k over -3. I'm going to solve for this k. So I'm going to multiply this -3 over and get k equals -27. Okay, now I just need some kind of equation that looks like in the form that I can graph it, right? So I'm going to go back to this equation here. And I'm going to use my constant to rewrite this as y equals -27 over x. And that looks like something I can graph, right? Whether you use your graphing calculator, you make a table of values, use something on your phone or your laptop, this is what I would graph. Again, there is another way to do it at the top, but that's the way I think is easiest to do it. So you're just doing that same process on this bottom sheet here. Okay. So on the next page, you have, so first of all, it gives you this like rule where given 2 points, after you were to graph an inverse relationship like you will be on the first page, take any of those 2 points, and here's what it's going to look like. And it tells you this at the top. So if those 2 points are x1, y1, x2, y2, any 2 points, then it tells me at the top here that x1 times y1 equals k, and x2 times y2 also equals k. So since both of these equal k, then we can say x1 times y1 equals x2 times y2. Because they both equal k, so that means they have to equal each other, right? So we're going to use this equation to do these problems at the bottom of the sheet. So it says, for number one, if y equals 10 when x equals 5, find y when x equals 2. Okay, so I'm going to label these based on the variables I have here. So it says y equals 10. Okay, I'm going to say that's y1. And then it says when x equals 5. Okay, x1 equals 5. It says find y, so that must be y2, when x equals 2. So that's the x of 2 equals 2. You're going to plug all these in where they go in this equation. And the only unknown you're going to have is y sub 2. And you can use algebra really easily to solve for that missing value. Okay, and that's all you're going to be doing throughout the rest of this page. You have 1, 2, 3, 4 variables in this equation, and there's going to be one that's undefined. So you're just going to do some algebra to find that one missing variable. Okay, and on the next page, it's just reviewing everything that you did on the first 2 pages. So you're going to graph, and then you're going to do the algebraic part using this equation. Okay, and you're also doing that on page 708. Graphing, and then the algebra. And again, for graphing, whatever process works best for you. It explains pretty in-depth here how they were graphing their equations. But I thought it was more straightforward the other way. But not all brains think the same, so use whichever way you would like. So after this, there's only one more packet. I think that has to do with scatter plots. So the next video will be the last, and we'll be talking about scatter plots.